Hey friends, MoNaCo. Oops, wrong file. Oop, there we go. So we are in our second video of our Unit 3 on the periodic table. Today we're going to talk about the arrangement of the periodic table. And today's Easter egg is the same as yesterday's Easter egg. Text me at MoNaCo P to hop in the list. And when you come to class, say, Mr. MoNaCo, I signed up for Remind.com. Check your list. I'll give you a STEM buck if you are indeed on the list. So, video 2, we're going to talk about arranging the periodic table. And so you're going to understand that the modern periodic table is arranged in groups and rows, aka columns and periods. Okay? These groups and rows are the first step in unlocking all the hidden information inside that periodic table. It's like the master cheat sheet. And if you really know the periodic table well, you get this master cheat sheet with you all the time. Okay? So, does this periodic table work like a map? The answer is yeah. It does resemble an element map to some degree. The rows and groups kind of look like Battleship to me. And so the rows and groups are going to act much like the table coordinate system. Like, you know, A1, you select my battleship, okay? We're going to call things by groups and rows and all that other kind of stuff. And so you're going to use it kind of like a coordinate system. So there's much more information hidden in that table other than just those coordinates, group, row. We're going to start to look at that as we go on through the rest of our movies. So the first thing you got to do is you're going to look at how the periodic table is made of periods and groups. As I mentioned, those are also called families, okay? The groups are families. Periods is just periods. So periods are the horizontal rows. They run left to right, okay? So here is one period all the way across. Potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, gallium, germanium, arsenic, selenium, bromine, and krypton. That is one entire period on the periodic table. So as we look through this period, using our periodic tables as a reference, we are going to tell the name, the group number, electron configuration, and we're going to make a Lewis diagram. This is all from the previous unit, but we're looking for patterns and similarities. So for element symbol K, we got ourselves some potassium. All right, if you don't know that, look at table S on the back side of your periodic tables in class. Potassium is in group number 1. It is in the first column or group on the periodic table, so we call it group number 1. The electron configuration is 2, then 8, then 8, then 1. And a Lewis dot diagram for potassium would be a K with a single dot up at the top. Okay? Now, I'm going to go on to the next element in the period, calcium. Okay? Calcium. It is in group number 2, and its electron configuration is 2, then 8, then 8, then 2. Its electron dot diagram is a Ca with 1 dot. Now, we are going to be skipping scandium, titanium, LEOs, all these orange ones in the middle for all intents and purposes, because we call those the transition elements. They've got some special little rules that they play by. So we're going to be jumping over to this one right here. Group, what would technically be 13. I like to call that group 3 because it's the main group elements. When we refer to the main groups, we refer to group 1, 2, 13, 14, 15, 16, 17, and 18. Either way, how you look at it, it doesn't matter. That's not what we're paying attention to. We're paying attention to what pattern I'm going to show. So we call this stuff gallium. It's a really cool metal. It would melt in your hand if we had a chunk of it. It is in group 13, also /3. Okay, main group 3, total group 13, main group 3. The electron configuration is 2, 8, 18, then 3. Okay, and the electron dot diagram would be a GA with 3 dots around it. 1, 2, 3. You know what? I just noticed I did not put 2 dots around calcium. I made a mistake. Caught myself. Haha. The next element we're talking about is germanium. And it is named after Germany. And it is in group 14, but main group 4. Its electron configuration is 2, 8, 18, 4. And we would give its electron dot diagram GE with 1, 2, 3, 4 dots. Okay. Now I'm going to stop filling this out here because you should be able to do this on your own because you're just copying off the periodic table. But I want to point out this thing right here. If you look at the last number in our electron configurations, notice it's going 1, 2, 3, 4. What do you think this number is going to be? What do you think this one's going to be? What do you think that one's going to be? So as you fill these out, you got to look for patterns. That's what we're looking for in the periodic table, is mostly patterns. Arsenic has 5 valence electrons. Selenium has 6. Bromine has 7. So that is the trend that you're going to notice here. As we went across the period, we kept adding one more valence electrons across into the outside shell. That is one of the trends in the periodic table. Okay, so let's look a little bit at what an octet is. An octet is a full valence shell. That means it's got 8 electrons, except for that pesky group period 1 elements for whom there are 2 electrons in a full shell. The only 2 period 1 elements are hydrogen and helium. Okay, so just know their electron configurations and where to find them. Remember, 8 is great. So there's something magic about that 8 valence electrons. All elements want to get it. So let's move on to some groups, vertical columns here. These run up and down. We got them color-coded in a rainbow here. So group 1, group 2, all these color-coded ones are the main group elements. So we call these the main group, main group, main group, because these are the main elements. These ones, these are called the transitions, the transition metals. We don't include those in the main group because they play weird, fun, awesome chemistry games that we can't really make very good trends with. So we kind of skip those for now. So we're going to use a periodic table to complete the table below for the group 1 elements and look for patterns. So instead of going across, we're going to be going up and down. Hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Okay? So we're going to start here with hydrogen. Okay? The electron configuration for hydrogen is just 1, and therefore its Lewis dot diagram is H with 1 dot. Lithium is in period 2, row 2. It has lithium as its name. Its electron configuration is 2-1, meaning it has 2 shells of electrons, 2 electrons on the inner shell, 1 on the outer shell. Its electron configuration is lithium with a single dot. Next element, sodium. Its electron configuration is 2-8-1, and its symbol is Na with a single dot. I hope you're noticing the pattern that I want you to notice here. The next element is potassium with an electron configuration of 2-8-8-1. K with a single dot. What we're looking for in this particular pattern is our valence electrons. As the groups, as we went across a period, so as we went horizontally from left to right, we kept adding one more electron to the outside shell. As we go vertically up and down, we're going to be adding another shell to the inner ring. So the same number of valence electrons always on the outside shell in the same group. That's kind of why they're going to end up reacting chemically very similarly. Okay? So practice this time around is not multiple choice. Practice this time around requires you to have watched your first 2 videos, and so therefore you need to put some time and energy into these 12 short response questions. Complete those to get your homework credit on homework check day. So now you should be able to complete practice packet page 14, 15, and 29, as well as remember, send me that text message, get your STEM buck for your little Easter egg. Okay, so now you got to know about those 2 basic patterns, groups and rows, that we're going to explore more about in the future. Thanks, everybody.